Welcome back everyone, Patrick here, moving on to another problem dealing with quadratics. So we're told that this half pipe here at a skate park is constructed, and we're told that its height above the ground relative to the horizontal distance from one end is modeled by h equals 0.3x squared minus 1.8x plus 6.2, and we have to figure out how deep is the half pipe. So notice here, here's the half pipe, so you get on over here or get on over here. Those are the ends. And so this represents the height above the ground. The ground is right here. And then this x value represents the horizontal distance from this end of the pipe. So for example, if we're like here, right, this would be the horizontal distance from this end, which extends down right there. And then this, obviously, from here to here would be the height. So they're asking how deep is the pipe. So what are they asking for in the diagram? Well, they're basically asking this right here for this distance, right? Because if we extend these ends as a dotted line, this would just be an open space, but if we extend it, it would be just a horizontal line like that. And then to this most bottom portion, which is going to be the vertex of the quadratic, that's the distance we're looking for. We're looking for this distance over here, and that's going to give us the depth of the half pipe. And then we're told that the actual half pipe here, this portion, which is a quadratic, is modeled by that equation that we're given. So question is, how can we find this depth? Well, what we can do is we can find how high this is, because we can find these points over here. So we could find how high it is above the ground. So we could find this height over here. And then we could also find the height of this vertex, like that. And then what we could do is we could take this height, subtract this height from it, and we'll be left with that height right there. So really we got to find the y value of this point, or the h value in this case of this point, or this point. This point's going to be easier to do. And then the h value of this vertex, and then we just find the difference between those h values. So what can we start with? Let's start with this point over here. Now notice this point. What's the x value of this point going to be? Well, the x value is just going to be 0, because notice that it's basically the h-intercept. So what we can do is we could take that equation and we could just plug in 0 for x. And what would we be left with? This goes to 0, this goes to 0, we're left with 6.2. So this point here is 0 and 6.2. Like that. We don't even need to find this point, because we know this point, it's going to have some kind of x value, but it's going to have a y value of 6.2, right? They're both going to be the same height. And so the top of the half pipe is 6.2 meters above the ground. That's this distance right here. It's going to be 6.2. Next thing we could do is we could find what's the vertex going to be, right? Because if we could find the vertex, then we can get this height, and that's going to be the height of this point above the ground. And so how can we get the vertex? Well, what we can do, notice that the equation that we're given is in standard form, and so what we can do is we could take it, complete the square on it, put it in vertex form, and then we can get the vertex directly. So completing the square, what would we do? Well, first we take out a 0.3 from these two, so we left with x squared minus, and then 1.8 divided by 0.3 would give us 6. This would be 6x plus 6.2, like that. You could check your answer. If you take the 0.3, redistribute it in the bracket, you'd end up with 0.3x squared minus 1.8x. Then we take the negative 6, we divide it by 2, and then we square it, so we'll have negative 3 to the power 2, which would give us 9. So we'd end up with 0.3 x squared minus 6x plus 9 minus 9 plus 6.2 like that. And so then we take out the minus 9. Let's multiply it by the 0.3. So we'd end up with 0.3x squared minus 6x plus 9. Negative 9 times 0.3 would give us negative 2.7. And then we'd have the plus 6.2 like that. Okay, and so from here, let's actually write it up here. We'll have the 0.3. This, it's going to be a perfect square trinomial. That's why we did this portion here. And that's going to factor into x minus 3 squared. And then negative 2.7 plus 6.2 would give us positive 3.5 like that. Right, so both of these here are the same. If you took both of those, graph them, you'd get the exact same quadratic. But now that it's in vertex form, that's really nice because we can get the vertex directly. It's basically 3 and 3.5. So that's this coordinate here that we were looking for. 3 and 3.5. And more specifically, what we want is that value, that 3.5, because that gives us the height of that right there, the distance from the ground to this vertex point, right? So this height is 6.2, this height right there is 3.5. And so what's the depth of the half pipe going to be? Well, it's basically going to be 6.2 minus 3.5. Right, 6.2 meters minus 3.5 meters. That's going to give us this right here. And when we do that, we end up with 2.7 meters. Okay, so that ends up being the answer to this question. So it's not too bad. It's just sort of making sense of the problem, understanding how this relates to that, and then realizing you just got to find this h value, then just take the difference between them.